The last chapter is actually really cool. It's about aliens.
Really?
On other planets. Cosmology, the two chapters before that, or the chapter before that's really cool. I like the one we just did with the asteroids. That's neat. You didn't like that one, did you? What about this one about Mars, Venus? You like Mars? You know what that is? That's video taken from a ship that landed on Mars. It's got a little scoop, and it scoops up soil and does experiments on it. We've landed 7, I think now, crafts on Mars. And there's one that we just landed there about a month ago that's as big as a Hummer, an SUV. It's rolling around on Mars doing all these experiments. It's pretty incredible.
Can it repair itself?
Cannot.
How if it breaks?
Then it'll be done.
What does it run on?
Solar.
Most of them run on solar, but I think this one has a nuclear battery.
How long will that last?
How bad would it be?
A lot longer than the solar. What happens with the solar panels is dust gets on and stuff, and it stops being able to take in sunlight.
You can't wipe it all.
Okay. Anyway, let's talk about some of the properties of planets, the orbital properties and physical properties. Here's a couple of things you need to keep in mind. Mercury and Venus both lie relatively close to the Sun and can be seen in the direction of the setting sun at night. If you want to find Venus and Mercury by looking at them, you have to look toward the Sun because they're close to the Sun. They're a lot closer to the Sun than we are. So when the Sun's going down in the west, look toward the Sun, don't look at the Sun. Look in that general direction, and after the sun sets, see if you see any really bright stars. Could be Venus. Mercury is so close to the sun that it's really hard to see at all. It's usually lost in the glare of the sun. You can only catch it right when the sun goes below the horizon, and Mercury might be sitting there. But it's pretty faint. But Venus, man, that's easy to see. Venus is the brightest object in the sky, other than the sun and the moon. Venus has these white sulfur clouds that surround the entire planet. If you were standing on the planet Venus, it would be cloudy every day, all day. The clouds never clear, and they surround the entire planet. And they're made of sulfur and sulfur compounds. So if you could smell them, it'd smell like rotten eggs.
Delicious.
It's also real hot on the surface, so it'd be hot rotten eggs. Doesn't sound too good, does it? There's no oxygen though, so you wouldn't be able to take a big breath. You wouldn't have any oxygen. You'd have to quickly put your mask back on. And the pressure of the atmosphere would crush you. But other than that, it's pretty cool. So here's the Earth. Here's the orbit of Mercury. Mercury never lies more than 28 degrees from the Sun, if you're talking about arc. So this is 90 degrees. Mercury is never more than 28 degrees from the Sun. 90 degrees. So Sun, Mercury. It's very close to the Sun. That's at its greatest. And then, of course, it goes around the Sun, so sometimes it's right behind the Sun, or right in front of the Sun, and you can't see it. Venus can get up to 47 degree angle from the Sun, which means here's 90 degrees. That's about 47. So Venus can get about that far from the Sun, looking at the sky. So look in the direction of the Sun at night or in the morning, after the Sun goes down or before the Sun comes up. If you see a really bright star, that's Venus. It's not a star. There's what Mercury looks like. Of course, there's the sun is set behind this mountain. And there's little Mercury. Jupiter happens to be next to it when they took this photo, but it's not. Jupiter's not always next to it.
Can you go back one?
And there's Venus. Venus is bright, man. Sometimes Venus, one time, there's a story about Venus came up, because the Earth is rotating, Venus comes up over the horizon. And so it's right on the horizon, and it happens to be centered right on some railroad tracks. And a train was going this way, and the conductor sees Venus right on the tracks and thinks it's another train, because it looks just like the headlamp of a train. So he slams on the brakes, thinking he's about to get hit. And it wakes everybody on the train up. And this train is screeching down the tracks. And it was just Venus.
Well, you should have not looked.
Scary. It comes right up right there on the tracks. We learn about these terrestrial planets first here. We're going to learn about each planet and what it's like. You can see its mass. They're all lighter than the Earth. Earth equals 1, so Mercury is only about 6% the weight of the Earth, the mass of the Earth. And the Moon is less than 1% the mass of the Earth. Venus is pretty close. And you can see over here the surface gravity. So if you were standing on Mercury, you'd weigh about 38% of what you weigh on Earth. If you're standing on Venus, you'd weigh about 90% of what you weigh on Earth. That's pretty close. Of course, the Moon is 17%. That's 1/6. That was on your test, wasn't it? It's a bonus question. There you see the escape speeds. The density, we've already talked about. The rotation rate. It takes 59 days for Mercury to spin around once on its axis. It takes negative 243 days for Venus to spin around once on its axis. It's not really negative days. It means it's spinning in the opposite direction of the other planets. Most planets spin around counterclockwise, as viewed from the North Pole, but Venus spins around the other way, real slowly. Why is that?
It's nearly tidally locked.
No, we think it's because it had a collision a long time ago with something that's spun it backwards. The Earth and Mars spin about once a day. The Earth spins once a day, and Mars almost once a day. It takes 1.03 days for Mars to spin around once. 1.03 Earth days. Of course, the Moon spins around once every 27.3 days. We already talked about that. Because it's tidally locked. It spins around once for every time it goes around. Every time it orbits. Look at the temperatures. Mercury's 100 Kelvin on the dark side. 700 Kelvin on the light side. Anyone know what the temperature happens to be in here right now? Kelvin? It's probably something you should know when looking at a chart like this.
287.
290, yeah. Somewhere about 290. That's the average Earth temperature. So man, real cold on Mercury on the dark side, real hot on Mercury on the light side. Venus is pretty much 730 everywhere, no matter what side you're on. Venus is the hottest planet. Mars is pretty cold. And the Moon is really cold on the dark side, and it gets hotter than the Earth on the bright side. those astronauts, they had spacesuits on, but when they'd walk into a shadow, they could feel, man, it just got, temperature just dropped about 300 degrees Kelvin. Now they had air in their suits that was heated to the right temperature, but you had to account for that. And you could still feel the difference. They didn't like walking in and out of shadows. Look at the pressure. Venus has an atmospheric pressure 90 times what the Earth is. That's like swimming in a swimming pool down 90 feet. You know how it starts to push on your ears when you go down in a swimming pool? That's the pressure you would feel on Venus, just pushing against you in all directions. Their atmosphere is so thick, it's like kind of like water. It's a lot of high pressure. Mercury and the Moon don't have any atmosphere, and Mars barely has an atmosphere. It's about 1% of the atmosphere of the Earth. Very thin air there. So, I know it's kind of boring to sit here and talk about numbers, but you need to get an idea of what it's like on these planets, because that's what's going to be on the next test. It's going to be say, what's it like on Mars? Is it hot? Is it cold? You're going to have to be able to answer these questions. You tell me, what's it like on Mars? Is it hot or cold?
Cold.
It's cold. The hottest temperature it gets on Mars is about freezing here on Earth. Let's look at the rotation rate of Mercury. This is hard to understand, so hang with me. Like I said before, it's so close to the sun, it's hard to see. It took them a long time to figure out how Mercury was spinning, but they finally were able to do it by shooting laser beams at it. And if you shoot a laser beam at the left side of the planet, and shoot a laser beam at the right side of the planet, they'll bounce off and come back to your detector. And on the left side of the planet, it'll come back faster than on the right side of the planet, because the Doppler effect. The planet is spinning this way, you see. Where's my globe? I need my globe. I use my moon globe because Mercury looks a lot like the moon. If Mercury's spinning around this way like this, and you bounce a laser off this side of it, the laser's going to hit this side and come back faster in less time because of the Doppler effect. And on this side, it comes back. It doesn't come back in less time, but the waves come back pushed together closer and farther. So you can tell how it's spinning. Actually, radar was used to first do that. So its rotation rate is 59 days, which is 2/3 of a year. So Mercury goes around the sun in, what is it, 80? What's half of 59? 28? 30, 60, 29.5. What's 59 plus 29? 88 days. Okay, so 88 days. Mercury goes around the sun in 88 days. And it spins around on its axis in 59 days. There's Mercury. There's what Mercury looks like through a ground telescope. But we know a lot better what it looks like because we have flown crafts to Mercury that orbited Mercury and took lots of pictures. This is showing what the waves do when they hit this side. They come back closer together than when they hit this side. That proved how fast it was rotating. But this is a video that shows you the way Mercury is spinning. See if you can follow this. See that little line there? Imagine that's a person standing right there and with the sun right overhead. After 15 days, the planet has spun around so that the sun is not overhead anymore. And after 30 days, the person's facing that way. After 44 days, that's half a year, the person's facing up. After 59 days, the person is facing this way. And if you notice, it has rotated all the way around once. Follow the arrows. See the arrow is pointed that way here at day 0, and it's pointed that way again at day 59. So it has done one rotation, one full rotation, and it is 2/3 the way around the sun. Then day 74. Day 88, and you're pointed completely away from the sun. So you've gone all the way around, that's 1 year, and now you're pointed away from the sun after 1 year. And then you follow it again, pointed there, pointed there, pointed there, pointed there, pointed there, and finally after 2 years you're pointed back at the sun. So 2 years on Mercury would be 1 day on Mercury. Because the way we define a day is how long it takes you to go from where you're standing to the sun in the same position the next day. That's 1 day. So if you're standing here on Mercury, the sun wouldn't be back overhead for 2 years. 2 times around the sun, and the sun's back overhead. It's a very strange rotation, very different from ours. This video probably shows it better than trying to follow all these arrows. A day that is 2 years long. Okay, follow this. This shows it really well. Yay, 1 day went by, 2 years went by. How cool was that? I want to see that again. That was freaking cool. If you don't think this is cool, well, you're just lame. You're wrong. This is cool. Watch this. Okay, here we go. Standing on Mercury. One day goes by, and 2 years go by. 2 Mercury years is 1 Mercury day. Something I read about in Popular Science recently was that Mercury spins so slowly. And remember I said the side that's pointed to the sun is real hot, and the side that's pointed away from the sun is real cold? Right? So there's got to be a place in between the two that's normal temperature. If this is hot and that's cold, then right in between the two is normal. There's got to be a spot, right? And that's called the sweet spot. That's where you want to be if you're on Mercury. So they could land a craft on Mercury in the sweet spot. And all that would have to happen is that craft would have to have wheels on it. And as the planet slowly turns, the craft could move. And it would only have to be moving at about 5 miles per hour to stay in the sweet spot. And the temperature would always be perfect. Isn't that neat? They might do that one day. Just rolling along. But you'd be in trouble if you got a flat tire. and your craft stopped moving, and then you'd slowly turn in either to the cold spot or the hot spot. That wouldn't be good. Are you following me? Any questions about this stuff? That's Mercury. What about Venus? Venus has a 243-day retrograde rotation period. That means it spins backwards from all the other planets. There's no explanation for this except the planet must have been struck by a large object that changed its rotation. It's the only thing they could think of that might have done this. 243-day retrograde rotation period. Why is it like that?
Got hit.
Got hit by something.
What was the last word?
Period? Object?
Didn't Mercury also get hit by something? It was a
it
flat
says
pole thing.
Struck by a large object that changed its...
Rotation?
This animation incorporates a window within a window, showing the change in phase, size, and brightness of Venus as seen from Earth.
Over here you're looking
This
at what
telescopic
Venus
view
looks like.
from Earth is shown alongside a main window that gives simultaneously the positions of Earth and Venus in their respective orbits around the Sun. A numerical information window gives many details of relevant qualities, such as the percent illumination of Venus as seen from Earth, the relative distance between the two bodies, and the magnitude and angular size of Venus.
Okay, check this out. Let's get rid of her voice and go to my better voice. Okay, check out Earth. Earth at the top there. And here's the Sun. And here's Venus way over here. Now you can see Venus from Earth, and that's what it looks like. It's almost full, like a full moon. Because it's on this side of the Sun, you see. The Sun here is shining on Venus, so it looks full. Like the moon sometimes looks full. And then we forward the video, and you can see Venus is traveling in its orbit faster than the Earth, so Venus is going to pass the Earth. And so as Venus gets closer and closer to the Earth, it starts looking bigger to us. If you look at this view from the Earth over here, it grows bigger as we get closer to it. But it becomes shaded. Remember, who was the first person to see that Venus had phases? Do you remember?
Galileo.
Galileo. Who said that? Who said that? Dewey McLean. How good are you?
Okay.
So now Venus and Earth are real close together. And now Venus is right in front between Earth and the Sun, and it's new. You can't see it. It's in the new phase. And then Venus travels on, and now it's getting further from the Sun, and now it's going back to full, because it's getting on the other side of the Sun. That's a pretty cool little graphic there. Now this shows the rotation of Venus. It's backwards, remember?
This animation begins by showing the orientation of a reference marker on the surface of Venus and how this reference marker changes with the position of Venus in its orbit, illustrating retrograde rotation and the length of Venus's day. The animation information then continues by showing a close-up of this rotation at the same time as an overview of Venus's orbital position throughout the course of an entire Venus year. Like the other planets, Venus moves counterclockwise in its orbit around the Sun, as seen from a vantage point north of the ecliptic plane. But unlike most of the other solar system objects, it rotates about its axis in the opposite sense. As a result, the Sun rises on the western horizon of Venus and sets in the east.
So let's go back to this first picture. So what they're saying is Venus orbits this way, like all the planets. All the planets are in orbit around the Sun this way, because that's the way it was spinning when the solar system formed. But it rotates opposite. The arrow there's kind of going backwards. So it's orbiting one way and rotating the other way. And that's just odd. We don't see that in any other planet except Venus and Uranus. Venus and Uranus both have retrograde orbits. Retrograde rotations. And we think it's because they both got struck by something.
Or maybe everything except for those two got struck by something.
But that's the way that the stuff was spinning around when the solar system formed. So everything should spin clockwise, counterclockwise, not clockwise. Mars is easy. Mars rotates just like the Earth does. Every 24 hours, 24.6 hours, Mars turns once. 24.6 Earth hours. So this is kind of an overview showing them all, the way they're spinning. And this is a good picture too, because it shows their tilt, the tilt of their axes. Mercury and Venus are both straight up and down. They don't have seasons. Remember, you have to be tilted to have seasons. The Earth and Mars are tilted. Do y'all know the angle that Earth is tilted at? You should know that by now. 23.5 degrees. So the Earth and Mars both have a tilt about 23.5 degrees. Mars is a little less. Venus and Mercury are both straight up. So the Earth and Mars have seasons, and Venus and Mercury do not. This shows the rotation. Mercury, Earth, Mars, all rotating counterclockwise as viewed from the north. Venus rotating clockwise as viewed from the north, in the opposite direction. Mercury and Venus rotating slowly. Earth and Mars rotate fast. Mercury rotates kind of the way it does due to a tidal locking with the Sun. But it's an incomplete tidal locking because Mercury has a very elliptical orbit that takes it far away from the Sun at some times, and that screws up the tidal locking. So it only faces the Sun. One face is pointing toward the Sun only part of the time. Here's a couple of transits. This is Mercury going in front of the Sun. In 1999 it happened, as seen through a ultraviolet telescope. Isn't that lame? And here's Venus doing the same thing. There it is. That's called a transit. Venus transit did a transit of the sun this past summer. Did anyone hear about it? It won't do it again for another 120 years. My dad and I took the telescope out, and it was real cloudy that day. And just for a brief moment, the clouds opened up, and you could see the sun, and with our little filter, you could see Venus in front of it. Look kind of like that. And then it was gone. The planet going in front of the sun from our perspective. It happens very rarely because the planet's so far away. It rarely goes right in front of the sun. Venus does it about twice every 100 years. Mercury does it about once every 3 or 4 years because Mercury's a lot closer to the sun. So you read 6.1 and 6.2. You can stop.